In this video, we will calculate an expected value of a game of roulette as described here in the problem statement. Also notice that this expected value that we're asked for is from the perspective of the player. So if the player is winning, they have this positive value of money associated with that, versus losing, they have a negative value associated with that. So we'll keep that in mind as we build our information. Another thing I want to do in this video is show how StatCrunch can help. So let's turn to StatCrunch. Okay, so let's start by naming this first column X, the value of the random variable, and P of X for the second column, which would be the probability of X. And we have two different cases that could happen. Either this player could win or lose. There are values associated with that. So the value of winning in terms of the player, or from the perspective of the player, is they gain $315. And it does say in the problem statement that they spend $9 and they get back $9. That's a wash, right? But then on top of that, they get $315 additional dollars. The probability that they win is 1 out of 38. So let's just express that as a decimal here in this cell. The next possibility for this game is that the player loses. So again, from the perspective of the player, they are losing $9. So we'll write here -9. And then the probability that they lose, since this is the only other option of the game, should be 1 minus the probability that they win. So let's calculate this decimal value here. Next, we'll go to Stat, Calculators, and Custom. Here we'll select our values in column X and our weights in column P of X, where the probabilities were. And then we'll select Compute. So what we see is a graph of this discrete random variable based on this probability distribution. But most importantly, what we need for the expected value is this mean. And we find it located here. Also notice that the standard deviation is given if you're asked for that in a different type of problem. So I've put the expected value, which is the same as the mean of the discrete random variable, here, and that's the expected value of this game. The last thing we're asked to do is find how much this player would expect to lose if they played the game 1,000 times. So if they expect to lose 47 cents for each game in the long run, then let's multiply that by 1,000 and get that they will lose $470. Notice that I don't need to include the negative symbol here because that is kind of captured by this term lose, and that's what we would see in the long run after 1,000 times playing this game.